uh, result finding the result finding. So after giving these, so we have to analyze, giving analysis type, which type of analysis, if it is a structural or thermal analysis, whatever type of analysis we have to give as an input. Then at next step, the given problem, we are going to checking the load conditions and other constraints. These and all we are going to check that in the solution type, and then we are going to solve, giving solve commands. So automatically the inside the problem can be solved. So after solving the problem, the result, we are going to see the result. So result taken is in the form of a graph, or it may be taken in the type of text message. Text message also we can able to get, and then other various processes available to find whatever may be the stress acting, strain acting, whatever deflection. These and all we can able to see in the final step. That is a solution. So the Ansys software, there are the 3 steps: pre-processor, post-processor, and solution type. Okay. So then we can move on to one simple problem like structural analysis. We are using as a structural analysis of 2D truss. Analysis of this is a simple problem. So analysis of 2D truss problem. So the example I will tell you this problem. So this problem to find. So what are the data we need to find? Nodal deflection, reaction force, stress of the system. So these are we are going to find, and the given values for this problem as Young's model value is given is equal to 200 gigapascal, and area value is given 3250 mm square. So the another important things in the Ansys software, you can solve the total full problems in the any one single unit. It may be as in the meter or mm square. So the given data we have to analyze the given data. Based on that we have to solve the problems. So first we have to get the values. So the n values, but depends upon this value we have to solve the problem. So if it is given mm square, so you can throw out the problem. You can use the all values in mm. Otherwise, if you are using meter squared or meter, so throughout the problem we have to use in the meter. So that is a main thing. Otherwise, the result will be different, and the error will be occurred in the final result. Okay. So this problem, the simple problem it is given, such problem. So this is the force acting in the, there are 3 places, there are force acting in the kilonewtons. So simple stress problem, press the distance, the equal distance is given 3.6 meter for each node. The height is given 3.118 meter. Height is given 3.118 meter, and the node distance between the node. So you can take this as a first node, key point. Key point or node. You can take anything. The first one, and this is second, 3, 4, 5, 6, 7. So 7 key points, and elements, number of elements, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So total 11 elements and 7 key points. So in this problem, Ansys the circles truss problem. So this type of problem we are using only for the number of elements. Each element we can divide when we are going for a machine. So we have to take in the truss problem alone. You can take single element. These are all the single element. So you should not divide this element. So divide this element. So one truss. So key point 1 to 2, one truss. That is one element. So no need to divide this 1 to 2. The key point 1 to 2 distance. We no need to divide this in several parts. Okay. So we can take this as a one element. So the total 11 elements, 7 key points. Okay. So these key points are used to draw the diagram. So the Ansys software itself, we can able to draw the diagrams. Okay. The first step of the Ansys software, first we are going to give a changing a directory. So as our name or the exam Ansys problem name, we can give as directory. You can change directory. So we can select the directory and create one folder. After creating that folder, in that folder itself, we can solve all the problems. Okay, this is the first step. So then you can go for the Ansys software. Open the software, and I told you already the element type. First, you have to fix the element type. Type of element used in the problems. The type of element here it is given truss element. The truss element can give us a selecting the truss element. After selecting the truss element, can go for the real constant or material property. Real constant. So the real constant we are going to give as the value of area. So some problems, the moment of inertia, we are going to give some moment of inertia. Here we are going to fix the real constant. Real constant depends upon the element. So what type of first step we are selecting the element. So based on the element, we are going to give a real constant. So we can select that element that can give a value of real constant. So here already it's a problem itself. They mentioned the area value 3250 mm square. So this value also we are going to use the mm. Is already given in the meter. we are going to use in that amount. So the real constant value we are giving is m square 3250 m square. Some problems we are going to do as real constant moment of inertia value. Then we are going to draw the diagrams. Draw these diagrams in the Ansys software itself. Before that, they are using some other drafting softwares, so that drafting software used to convert and import from the drafting software into the Ansys. That is will be generally scary. So here we are using to draw the diagram with the Ansys software itself. So Ansys software, so the modeling, you can go for third step as modeling. Modeling step. In the modeling step, we can select the key point. So the number of key points here already produced is given as 7 key points. We can take this 7 key points. We can draw the diagram. So each key point, the distance is given. The first key point has x value and y value. Both are 0, 0. So the 0, 0, this is 0, 0, first key point. So there's no distance between x and y. And then the second key point, can go for the second key point. The second key point, the height of the second key point is given 3.118 meter. And then the distance of the second key point point is half of the element. So 3.6 meter, so 1800. 1800 mm. 1800 mm. So that the x and y value, x distance as 1800, 1800, comma 311 feet. 311 feet is a second key point. So if it is giving this value, so directly it is around the 1 and 2. Okay, then you can go for the third one. Third one is again, it is x-axis 0, y-axis 3600. 0, 3600. Third one. And fourth one, again, you can go for the fourth key point as again the same thing. The distance between x-axis, you can add the 3.6 plus 1800. So this is a fourth key point as 5400. Sorry, this is x 3600, y is 0, and 5400, comma 3118. Like this, we can go for the 50 key point as 7200, 0, 60 key point as 9000, 10,800, comma 0. So you can give this value x and y axis value and selecting the key point, you can model that diagrams. After modeling, we are going to machine. So machine that so the properties already given. The geometry properties everything is given, and then a meshing here. So you can select the mesh size. Fourth one as meshing. So selecting the mesh sizes. I told you that first problem you can select the key point 1 to 2 descend as one element. That's not giving us the size of the mesh. So you can give mesh size as each element, each layer, give it one element. Okay, can select the one element. So then you can work. So beam problems, you can select that 50 or 100 whatever divisions you can select. You can select that key point distance 1 to 2. You can divide into 100 or 1,000, whatever you want. You can divide the divisions. That is called as finite element. You can divide that several elements. But here, the first problem alone, you are going to select 1 to 2 as one element. So, after selecting the element, we are going to meshing that again. Meshing again. So after completing this, the meshing is complete the meshing. Okay. And then the fifth one, after meshing analysis type. So it's a sector analysis or thermal analysis, whatever. We are going to do the analysis type. Then we are going to give a constraint, boundary conditions. Boundary condition. Boundary condition means, so the first key point, you can look at the first key point. It is a fixed support. Here we are using the fixed support. There is no movement in the first key point. So it is arrested, and final last one, it is in the roller support. It is a roller support. So it is moving on the x-axis, it's moving, and y-axis will be fixed. So this is the called as a constraint. This is a constraint. So this constraint you can give as, so this is a fixed support. So we are going to arrest, applying constraint, selecting apply constraint, we are arresting all degrees of freedom. In the fixed support, we are going to select all degrees of freedom as arrested. Okay. So here it is a roller support. So the x-axis moving. So y-axis alone, we are going to select the constraint. Okay. So it is a fixed y-axis. We are going to fixing the roller support. So this is the another point. And then we are going to apply the load. These are forces. Applying load. So this is the next step, applying load. So I told already, is all the loads are acting in the downward direction. All the loads are acting downward direction. So the 280 kilonewton are acting at 1, 5 and 7, 280 kilonewton. The 210 kilonewton is acting at the third key point. You can select the particular key point and give a load is acting. So it is selecting the downward direction in the y-axis, downward direction. The value will be given as in the applying load. After applying the load, now is a final step. We can go for the solve. So solve the problem. Solving the problem. So the solve, automatically the Ansys software will be solve the problem. And after solving this problem, we are going to see the result. Going to see the result. So the result in the form of a graph. So the deflection. So the load is acting downward direction. So it may be a deflection will showing in the graph. So in the form of graph or text message, we can able to see the result. So this is the procedure to solve the problem. We are going to take all these values. So these nodal deflection and the reaction forces and success in the result column. So directly it is given the nodal deflection in the y direction, not in the x direction, y direction, and the reaction forces and success. After that, we can solve the same problem in the manually, and we can compare the result, manual result and the Ansys result. Okay, so this is the final steps in the using Ansys. Okay, So thank you for your attention. So the next class we can discuss the some other problems used in the Ansys. Okay. Thank you all.